Welcome back to Math 104. We are looking at these two events, F, the first child is a boy, and L, there is at least one girl, in our experiment of selecting a family with 3 children and noting the birth order in terms of boys and girls. So our first task is to draw a Venn diagram for F and L and label it with all the outcomes of the experiment. So here is a Venn diagram. It's always important to draw this rectangle surrounding it. So everything that's inside the rectangle represents the entire sample space. To begin the labeling of each basic region with the outcomes that are in it, it is often easiest to work our way outward from the overlap region in the middle. This contains all the outcomes, that is, all the words, starting with a B and having at least one G in them. That's because this region is inside the F circle, hence starting with B, and also inside the L circle, hence having at least one G. And I claim that those are all the words fitting that description. In the F-only region right here, inside the F circle but outside the L circle, we have only BBB, a word beginning with B and not having any G's in it, because it's outside of L. In the L-only region, we have all the words with at least one G, but not starting with B. So they do start with G, and they have at least one G, so everything that happens after that initial G could be anything. GBB, GBG, G, GB, G, G, G. And there we have it. That's it. There are no more outcomes to write anywhere. There are only 8 outcomes in this experiment. So they're all accounted for, meaning that there is nothing left to write in this outside region. This makes sense. If an outcome is outside the F circle, that means the first child has to be a girl, but if there's at least one girl, then the outcome must be within the L circle. An outcome cannot be outside both circles. This example shows that it's possible to have an unequal number of outcomes in each basic region, and in fact, even to have a basic region with no outcomes at all. Assuming that all outcomes are equally likely, find the probability of L and of F union L. There are 7 outcomes inside the L circle out of 8 outcomes total, so the probability of L is 7/8. Notice, by the way, that the probability of F that we had found in the previous example is 4 out of 8, and we see it again here. There are 4 outcomes inside the F circle. How about the probability of F union L, the outcomes that are in F or in L or in both? Well, that is all 8 out of 8 of them. As a follow-up question, what is the probability that both F and L occur? The event that both F and L occur is represented in the Venn diagram by the middle region, the overlap between the F circle and the L circle. There are 3 outcomes in this region, so the probability of this event is 3/8. This brings us to our next operation on sets, our next operation on events, that lets us create new events out of ones we have already defined. The intersection of 2 events, E and F, is the event denoted by this symbol E intersect F, which consists of those outcomes that are both in E and in F. In words, E intersect F is the event that both E and F occur. What we just found in our example is that the probability of F, that the first child is a boy, intersect L, that there is at least one girl, equals 3/8. It is often helpful to represent an event by a shaded Venn diagram, where all the basic regions in the event are shaded in, and all the other basic regions are left blank. For example, if we draw a shaded Venn diagram for F union L, then all 3 of these basic regions are going to be shaded in, the 3 basic regions that are in the event. I'm trying to draw around the outcomes here so as not to obscure them too much, but it's really the entire regions that are meant to be shaded in. And this is representing F union L. The outside region is not inside the event, and therefore it is left blank. So all the regions that are shaded, the outcomes in those regions are in the event F union L. For F intersect L, it's only this inner region here, this middle overlap region that is in the event and whose outcomes are contributing to the event, only those 3. So we shade the middle region and leave everything else blank to represent F intersect L. To understand how F union L is related to F intersect L, we join our friends Pat and Sam, who are having an argument. Sam says F union L contains all the outcomes in F, together with all the outcomes in L, so the probability of F union L should equal the sum of the two individual probabilities. Sam says it should equal P of F plus P of L. Pat disagrees and says... Before going on to the next video, think how you would finish Pat's sentence. That is, what objection you would make to Sam's argument that the probability of the union should equal the probability of F plus the probability of L.